Hello, algebra students. Mr. Lawrence here, and I've got to tell you, if you're watching this video on Monday, I am very, very proud of you. You worked very hard, and you prepared, and you found yourself to the right of this black line. Yeah, the other students that are still in the classroom are seeing the same graph, and they are not the ones above the line. And what that means is that's the CD line right there. 14 is the lowest score you could have gotten on the test and earned a C. These people over here actually picked up 2 bonus points and got more than the points possible. Well, look at this. We had 1, 2, 3, 4, 5, 6, 7, 8 people get 20 out of 20, and then 2 more get 22 out of 20, and look at how many are very close with 18 or 19. So anyway, I'm proud of you. You did nice work. Now, these folks are going to be doing some extra work, and in a day or two, I may call on you to help them out. But anyway, we're going to get you folks ahead because you don't need to review stuff. You need to press on. You're doing a great job. By the way, there's a couple of you in this group that have never scored so high before. I'm exceptionally proud of you, and that's why I took the time to send some of you and your parents emails. One person I tried to send an email to you and your parent, but it got bounced back to me. So you got the email, but please share that with mom because I want her to know my opinion of what you're doing. Anyway, so let's get on with it. Today we are going to be learning how to solve systems by graphing. So we're going to take our graphing skills and we are going to apply them in a new way. So you obviously have to know how to graph from slope intercept form, point slope form, standard form, etc. Well, we're going to be solving systems of linear equations. And a system, it means that there's more than one equation. Yeah, normally we graph our lines on one graph. Today we're going to be graphing 2 lines on the same graph. Now, a system doesn't have to be just 2 equations. It can be 3 or 4 or 5, but it means 2 or more equations. And if you're wondering, like people say, when am I ever going to use math? This stuff is extremely useful. Electrical engineers use it, electricians use it, anybody who works with flowing of water. Your sewer systems are designed using this type of algebra. Wind power is designed using this type of algebra. Very, very practical in the real world. One of the reasons we can have a modern society because of algebra. Anyway, let's get down to it. This is pretty easy. As you can probably guess, you're going to need some graph paper and a ruler, but for right now you can just kind of take some notes, make some sketch graphs, but when you go to the homework. So anyway, the first thing I'm going to do is I'm going to graph this red equation. I notice it's in slope-intercept form. And so put the y-intercept at -4, and I'm going to rise 1, run 2. I'm going to rise 1, run 2. Okay, and I'm going to draw my line. Oops, what are we doing there? Okay, let me get this in place. That's looking pretty good. I'm going to change its color and all that kind of stuff so that you can differentiate between them better. So we've graphed part of the system. Now, I guess I should tell you what we're after. We're actually after the place where the 2 lines intersect. Yeah, that's what we're after. We're after a point of equilibrium, a place where they share the x-coordinate and y-coordinate. So let's see here. On this problem here, the black equation, it looks like my y-intercept's kind of ugly. I don't want to deal with the y-intercept. So I'm going to deal with the x-intercept, which is going to be 8, 0. And then my slope is -1/3. So if I rise 1 and go back 1, 2, 3, rise 1 and go back 1, 2, 3, I can now draw my line. Now, if you were listening just a second ago, you realize I've actually already solved this system because I told you we're after the point of equilibrium, or the place where the 2 lines intersect. And if you look, it's sometimes a little difficult here on this smartboard to be exact enough, but if you look, the place where these 2 lines cross is right here. So the solution to this system is the point 8, 0. And there you go. Yeah, pretty easy stuff, huh? But you have to understand how to graph to be able to do it. All right, here's two more. Uh-oh, I don't think that's supposed to be 0. Okay, well, that's all right. We can do it with 0. That's not a problem. It just doesn't look right. I think something got erased unintentionally. So let me see. Let me do the green one. Looks like it's going to go through the origin, right? Because the x-intercept is 0. And then the slope is going to be 2/5. So I'm going to rise 2 and run 1, 2, 3, 4, 5. Okay. So I'm going to draw my line. 2, back 5. Yeah, it's going to look something like that. And I'll change its colors. All right, put an arrowhead on that end. And make it green. There we go. Okay, the blue equation looks like it has an x-intercept of -9, and then a slope of -2. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Oops, down 2 over 1. All right, now I haven't extended my graph far enough, so let me do that. Make this green one go a little further. And there we go. Now the problem with this problem, that's why I think there's a mistake in it, but we can still solve it, is that you can't find the exact solution, can you? No, you see the point of equilibrium is here, but you don't know the exact coordinates. You know the x-coordinate is like maybe -7.5, and the y-coordinate looks like it should be -3, but we can't be 100% sure unless they're crossing at an exact intersection. Okay, that's a downfall of solving a system by graphing, is that they may not cross at a pretty intersection. Okay. By the way, you guys can get a jump on your study plans for this. For 6-1, here let's talk about what should go in your study plans. I don't think I need to do a ton more examples. Of course, you can ask in class, and we're going to practice. But first of all, the title was Solving Systems by Graphing. The purpose is to solve a linear system of equations by graphing. Yeah, that's the purpose. Okay, now why is it useful? Well, graphing is relatively easy to do if you know your forms. A drawback to it is that lines don't have to intersect at pretty places. Okay, I'll tell you what, let's do one more example here. Let's see if we can't get two pretty lines here so they cross at a nice place and you can tell the solution. All right, yeah, I apologize. I'm not sure what happened with that problem, but that's okay. We'll make up for it right now. So let's say we have this equation here. Y equals x plus 3. Okay, and then our other equation, let's see, our other equation is going to be, let's see, we're going to make it equal to -6. And we're going to go with 2x. And then let's go with plus y. Yeah, let's do that. All right. So graphing the first equation, I have a y-intercept of 3 because I'm in slope-intercept form, right? And then I have a slope of 1, or 1 over 1. So I'm going to get a line like this. There we go. And remember to always give your lines arrowheads. That's why I'm taking the time to do this. I'd much rather just say, okay, let's move on to the next line, but I'm trying to model for you. Okay, so I'll make that a little bit thinner. All right, now the red line red line is going to have an x-intercept of negative, oh, I'm sorry, a y-intercept of negative 6. And it looks like the slope is going to be negative 2 over 1. Negative 2 over 1. Oh, and look at that. Look where they're going to cross. Notice how I put a whole bunch of points on there? I was trying to find the place where they cross before I drew my line. It's kind of a way to check my work ahead of time. Okay, so the solution to this system is the point negative 3, 0. Yes, it is. All right. And there we go. Looks like that might be off a smidgen. Yeah. Oh. Okay. All right, there you go. So we solved systems of linear equations by graphing. You can go ahead and give the homework a try. All right, Mr. Lawrence signing off. Have a good night, everybody.